Welcome back. Uncle Pythagoras invites you to complete all the theorems that we need to know before we sit for our final exam. Theorem 7 now says that a tangent to a secant is perpendicular to the radius at the point of contact. Here is your secant, center O, the radius. Here is your radius. Then ABC is the line which touches the secant at only one point. That line is called a tangent. Now, if you have a situation like this, it tells you that this is, here is your secant, center O, then your radius, and the line that touches the secant at only one point B. So it means that the tangent to a secant is perpendicular to the radius. This is your radius, this is your tangent. In this case, this will become that there you have your box. That box indicates what? 90 degrees. That 90 degrees means OB is perpendicular to ABC. Therefore, you can conclude by saying that ABC is perpendicular to OB. Then, we can conclude by saying, if we may call this one B1 and B2. Therefore, B1 is equals to B2 is 90 degrees. Therefore, ABC is a tangent to secant at only one point. That point is B. Thank you very much. This, you don't prove any more things. This is just a statement that you are given. So whenever you find a problem like this, you have to tell them that this is a line that is it touches the secant at only one point, which is perpendicular to the radius OB. Here, OB is our radius. So that radius is OB is perpendicular to ABC, which is your tangent. This is your tangent. So as we go along, we are going to grab problems that want us to understand the situation by which the tangent ABC is perpendicular to the radius. Then you have 90 degrees at the end. Then you must know this. There is no proof for this one. This is just a statement that you have to bear in mind. Thank you very much. I'll see you in the next videos where we have to prove all the theorems before we can start embarking on solving the problems in the cyclic geometry. Thank you very much.